Hello, this is Tim Malloy with video 1-1 on electric fields, first video of E&M. Right off, I'm just going to erase a couple things on the screen here so I can read the problem and not confuse you with a ton of visual garbage. So here we go. A proton is projected in the positive x direction into a region of uniform electric field. Explain that later. The uniform electric field equals negative 6.7 times 10 to the fifth I hat newtons per coulomb at time equals 0. The proton travels 6.7 centimeters as it comes to rest. I'm going to put those back. Okay, so first part, I'm going to read all the questions actually. So first, determine the acceleration of the proton. Well, the number, we'll get to that later, but we do know the direction is negative x as the proton does come to rest, and we are initially launched in the positive x direction. So we can put negative x for that. Again, initial speed, positive x set over here. And then I wanted to draw this diagram. So here's our proton, this little button, and it's in this electric field. Now, if it's coming to rest, then the electric field has to oppose it, which is what I'm doing right now. And that's you'll notice it's the opposite direction of the initial velocity, which I represented by this arrow. So again, initially traveling positive x, acceleration in the negative x, though, will slow it down to a rest. Okay, so now I'm going to do some, calculating the actual answers, if you will. First off, acceleration. So the goal that here, at least conceptually, is go from electricity to kinematics. So where you want to start with that is Newton's law of force equals mass times acceleration, law of acceleration. And then we can actually do A equals F over M. And then we can plug in, for the electric force, we'll plug in charge times electric field. That's really the big step here. And fortunately, we do have the charge of a proton. That's a known value. And we are given the electric field as well. And then the mass of the proton is also a known value. Simplify all these, we get acceleration equals negative 6.43 times 10 to the 13th meters per second squared. What does the negative tell us? Negative direction, opposite of motion. So again, my not really prediction, but really educated determination from the beginning was correct. So and then part B asks us the initial speed of the proton. Well, what do we have? We have displacement over here, given the question. We have displacement, we know of acceleration. We know that the final velocity is 0, so we're going to use this equation dealing with velocity, acceleration, displacement. Well, I guess two velocities because we want the VOs, the velocity initial squared. So here you go, pretty well-known kinematic. For final, plug in 0. Acceleration, plug in what we just calculated. Displacement, convert from centimeters to meters. Put velocity, initial velocity, subtract, so you get it on the one side, then times -1. It's just basic algebra simplified to 2.93 times 10 to the 6 meters per second. All good. So then determine the time interval. Just going to go over this briefly again. Basic kinematic, basic stuff. Plug in, solve for t. T equals 4.57 times 10 to the -8 seconds. So this is a very quick motion, very quick action. And then I did check everything. So there you go. And here's some takeaways, is that A equals charge times electric field over M is key. And hey, welcome to E&M. We're back. I'm actually kind of looking forward to this semester because I'm planning on doing computer engineering, and I've just been getting a whole lot more curious about electricity and circuits and whatnot. And, I always have enjoyed E&M more than motion. So thanks for watching, and see you later.